There are two types of special right triangles. The first one that we're going to talk about is a 45, 45, 90. So if you have a right triangle, and this is 45 degrees, and this is 45 degrees, one side we can call X, and the other side has to be X. This is an isosceles right triangle. So the only way you can have an isosceles right triangle is for both of these to be 45 degrees. So if this is X and this is X, to find the hypotenuse, we do the Pythagorean theorem. So x squared plus x squared equals, we'll call this y squared. So 2x squareds equals y squareds. And then we're going to take the root of both of them. So it's y equals the square root of 2 times x. So this side is x root 2. So the ratios of the sides of a 45, 45, 90 are 1, 1, root 2. Because what I mean by ratios, you could write this as x, x, x root 2, x, x, x root 2, but that reduces to 1, 1, root 2. That's how I get 1, 1, root 2. So any 45, 45, 90 triangle is going to have the same ratios. So we're going to use what we learned last chapter with similar triangles to find the missing side lengths. So down here, this first one, it's a 45, 45, 90. So what I'm going to do is, in order to find x, x is a side length and not the hypotenuse. It's one of the legs. So remember, we have the legs of a 45, 90 are 1, and the hypotenuse is the square root of 2. So I'm going to set up a ratio of similar triangles. I'll set up the similar triangle that I'm going to use over and over again. This is square root 2, this is 1, this is 1. So I'm going to use similar triangles and do 2 is to x as 1 is to 1. Well, x has to be 2 in that case because it's an isosceles triangle. So that one's not too difficult to find. So now I'm going to use this other ratio, 2 is to y as 1 is to root 2. So 2 is to y as 1 is to root 2. And I'm going to solve for y. So I'm going to cross multiply. Y equals 2 root 2. That's my answer. So x equals 2 and y equals 2 root 2. So you're going to use similar triangles. Let's look at the next one over here. Okay, I'm going to draw my similar triangle again in the same orientation. So my ratios are 1, 1, root 2. So if I'm solving for y, I'm going to use these two ratios. 14 is to y as root 2 is to 1. And then I'm going to cross multiply. So 14 equals y root 2. So to solve for y, I'm going to divide both sides by root 2. So y equals 14 over root 2. But remember, we want to rationalize our denominator. So I multiply the top root 2 and the bottom by root 2. So it's 14 root 2 over 2. Because root 2 times root 2 is 2. And at the end, this can still simplify more because 14 divided by 2 is 7. So this is 7 root 2. That's y. Now, since I say isosceles, z is the exact same. It's 7 root 2. And then the next one here, this triangle, I'm going to set up my 45, 45, 90 in the same orientation. 1, 1, root 2. So if I'm trying to find this missing side length, this is an isosceles triangle, this one has to be 5 root 2. So to find this one, we'll let this be x. I'm going to use a proportion. 5 root 2 is to x as 1 is to root 2. And I cross multiply. So 1 times x is x. 5 root 2 times 5 root 2 is 5 times 2, which is 10. So this side is 10. So you can draw your right triangle. You also might notice a pattern that it's this times root 2. So you could just jump right away to that. 5 root 2 times root 2. It's whatever the short side is or the leg is times root 2, which is just 10. Okay, another one. So again, it's isosceles, so this is root x. So to figure out this side, you could draw your similar isosceles right triangle. So this goes 1, 1, root 2. And you're trying to find this x right here. So you could do 1 is to root 2 as root 6 is to x. And then cross multiply. So x equals root 2 times root 6 is root 12. But remember, we know that we can break this down into 4 times 3. So it's 2 root 3. And the last one. Okay, the last one. So draw right triangle 1, 1, root 2. So to figure out, this is the hypotenuse. So I don't know what this is, but this is the exact same. So I'm going to do a ratio. 6 root 3 is to x as root 2 is to 1. So when I solve, it's going to be 6 root 3 equals x root 2. And then I'm going to divide each side by root 2. So if I don't want to leave this square root in the denominator, so I'm going to rationalize it by multiplying the top by root 2 and the bottom by root 2. So what's going to happen with root 3 times root 2, it's going to be 6 root 6, and then root 2 is just 2. So you can still simplify this as 3 root 6. There's my answer. So the two legs of the isosceles right triangle are 3 root 6. So set up your triangles and use similar triangles with the ratios. So no matter what, in a 45, 45, 90, it's going to be 1, 1, root 2. That ratio stays the same.